we have a team, we are building a team. It's a think tank group of trying to see how we can influence women's inclusivity in water and inclusivity of water in all the agendas of any business or any community. So I'm always wanting to ask this. So this is good, not bad. 39% of you are women, and we would like to see where we become 50 or more percentage. So that's the idea. Thank you for your response. So now let me just share my presentation. 1 minute. So today we all have gathered to talk about this topic of integrated urban water management. So basically the very title therefore suggests that perhaps we are not integrated. That is why we need to talk about integrated urban water management. So I think the way I have structured the presentation is that we will look at, why do we need this? Why do we need to have an integrated? And the way we will try to appreciate and understand that is by looking at taking stock of currently we have an unintegrated water system. So we will try and see what is the outcome of that system. And that will help us appreciate the need for why do we need to have an integrated system. And after that, we will kind of, understand by looking at that, what are the things we need to be integrating within integrated urban water management. And after that, I will, lastly, through case studies, 4 case studies from Australia, I would like to show how does an integrated urban water management look like on ground. When we do it, what does it look like? So that will really help us to, tangibly understand. It's a very abstract concept. So the examples will help you to really make it concrete. So this is the way I'm structuring it, and also because it's a very long presentation, so that it doesn't become boring and most of you don't go to sleep. I will be asking some quiz and like a poll. It will be a combination of poll and quiz questions. So please be alert and see how many you are able to answer. Okay, so we'll start. So I want to first begin with that we are standing at a stage in time where we have a long history of urban water system and urban water services, the way it has evolved over 100 and more years. So how do we understand how the evolution has taken place will kind of give us an idea of how we have as humans thought about our cities and the water services for the city. So there is a very nice famous diagram. It is developed by one of my colleagues in Australia, Dr. Rebecca Brown. So what it shows is that in the beginning, right in the beginning, of course, as civilization and as a city became a developmental area, we are always concerned about the supply of water and that do we have access to water for our civilization. So it all started by having a water supply focus, and that became a water supply city, primarily just a water supply system. And then we suddenly realized we also have to take care of the waste or the sewage that is generated as a result of the water. And then there was a lot of diseases that was happening when you were not separating the sewage from the water. So you created a new system to make sure that the sewage is taken away safely for the public health reasons. And you also had a water supply and a sewage, and your city became sewered city. After the water supply city, it became sewered city. And then there is also, we need to take care of the rainwater that falls on the urban areas, because before the urbanization, usually it is not so much of a problem because there are a lot of soft surfaces. But as the more and more hard surfaces increase with the city getting urbanized, you suddenly find that there is a lot of storm water you have to deal with. And today we are all in a stage where people are stuck in traffic. So this became the reason for creating a drainage system to get rid of that water that is kind of flooding the properties. So the whole idea was, let us drain the city, let us push the water, storm water out of the city so that we are safe. So that became then a drained city. And then as we started to understand that we are causing impact on the environment when we are discharging the sewage, when we are discharging the storm water, we started realizing the impact we were having around the rivers that was nearby. And that made us think about, okay, we think we need to really, for the health of the waterways, we need to treat the sewage and then only dispose it. And that gave rise to what we can call as a waterway city, that we became more conscious of our impact on the rivers and the lakes, which was in the neighborhood or as part of the city. And so this is how we keep, as humans, we have been evolving the city's urban water system. And then more recently, in the last 2 decades or so, we have started to really understand, because we started reaching the limit of the water resource, because the population is keeping on growing in the cities, whereas the source from where we are drawing the water doesn't really grow. It may recharge, but it doesn't grow in quantity. And that has the limit on the water that we have versus the population that is growing, made us think about recycling, conserving. How do we, do we really need water, drinking quality water all the time? When we know that 80% of our needs are not really for drinking or consuming it in. So how can we create what we call as fit for purpose water? So these are the ideas that started to come in. And of course, more recently, more advanced cities who are more progressive in their thinking about water, they have started to think about the climate change. Climate change is going to cause more floods, more droughts, more frequently and more intense. So how do we need to make sure that anything we build for water management, it has to be make the community resilient. We cannot also build in too much, because we don't know, the climate change has brought in a lot of uncertainty. And in order to deal with the uncertainty, we need to build adaptive infrastructure. And these ideas have slowly started to emerge. I wanted to show this because water is never in isolation of the city. You have to understand how the city has been and water system has been growing together. And that is why I'm showing this diagram. So it sets a context, and it reminds us that water is within a context of the city. So based on this, I have a small question to ask you all. Where does, whichever city you may be in, I think some of you may not be in Bombay, but think about your city and look at this diagram and tell, what do you, this is maybe in the chat box, you can write, what is the, where does your city sit? Whether it's Mumbai or whatever your city, do you think it's a drained city because it's already covered water supply, storage and drainage? Do you think it's a waterway city because you've started to treat the sewage before you discharge? Water cycle city? So where would you put your city in the spectrum? I would like to, I will request you all to respond in the chat box, so that, then Deepakar will just read out what the answers are. So you have to pick one of the 5 options. Okay, so I hope all of you are participating. So may I request, okay, I can also look at it actually. Yes, I'm able to see. Okay, waterway city, drain city, water supply city.
Good morning, ma'am. Can we see the table again, ma'am? Table.
A table, this one? Oh, the chart. The previous
chart. Yeah, sure. The chart, sorry.
Sure. Yeah, here it is. Can you see?
Yes, ma'am.
Yeah, please. Okay, so it is just for you to reflect on and think about that. We really, each city is in a different position. Some of you have written water supply city. It looks like it's possible that you may not have the thing like sewage system completely covering your area, and that's understandable. So I can see this is why we need to really think, what's happening within your own city. Okay, so, and yeah, I think it's great that Dipankar has actually put out in a form of a poll. So if you feel, why don't you all, kind of respond, and we can see how many in your population is, what type of city. Thank you, Dipankar.
Yes, thanks, madam.
No problem. And you may start doing the same for the other questions. So, we might have the poll ready.
Just getting it ready in the background.
Sure. That's good. Thank you. Okay, please submit your answers in the poll or in the, that's okay. Next ones, we'll do it on the poll, okay? So that's good. This was just for your reflection. There's no right or wrong answer to this. It is just that, every city is different. Okay, so now let's move ahead.
Yes, Dr. Bhakti, madam.
Yes.
Can I request for 30 seconds for the participants to complete this poll?
Sure. No problem. Please take your time. No problem.
Participants, the poll is open for 30 seconds. Kindly submit your answers.
Yeah, please do. It doesn't take time to just put a click button, right? So why not? And it will be nice to see the answers, all of us collectively. Okay, so we have most of them are having, they don't have a sewage system, enough coverage. So water supply city, sewage city, great. So our aim is to get to water sensitive city. Okay, that is our aim, and integrated urban water management can show us a different kind of way, which is more interesting than the traditional way we have been doing things. So that's why I want you to get the courage that, don't lose heart, that we can easily go from water supply city to water sensitive city straight away. That's the beauty of integrated urban water management. Okay, so now, as I said, we want to really understand why do we need to integrate. And as I said, we'll do that by taking stock of what has happened or what is the outcome of the unintegrated urban water management. So of course, I want to take the example of our own cities in India. So before I want to share with you, and we will look at some facts and figures, okay, in order to understand the outcome. So before I share you one of the figures, can you guess, I mean, again, it's a question, is there a poll ready, Dipankar? Have you got a poll for this question? Dipankar, are you there?
Yes, madam, it is ready.
You have a poll for this? Yeah, maybe put it out. So I'm asking you to guess what percentage of our country's population is currently under extremely high to high water stress. And of course, water stress basically in simple terms means your water demand is much higher than the water that you have available. So the water availability is less and water demand is very high. So there's a big imbalance between what you need and what you have. So what percentage of the country's population is currently under extremely high to high water stress? So please, this doesn't take time, just you have to guess an answer, and then we will, I'll reveal you the answer. But, it's always, you will remember better when you have guessed it and you got it right or wrong. So again, we'll keep it on for just 10 seconds. I don't think we need 30 seconds for this. You don't have to think, you just have to pick a number. So shall we? Yep, good. Great. So, all right. So many of you think it's somewhere between 20 to 32. And I think most of you, 54% got it right. I mean, 47%. So the correct answer is indeed 54%. So 54% of India faces high to extremely high water stress. Okay, so this is the outcome. As I'm saying, it's just a fact. So this is what has happened in the way the current water system has been serving us. Then the next thing I wanted to show you is this. Now in this chart I have basically put, the water supply and demand in every city. So, the brown one tells what the demand is and the current supply capacity of the city, water supply capacity. I want, maybe in the chat, I would like you to, there's no poll for this, but I want you to tell me on the chat, what is this, look at the graph and tell me what is a very striking thing you observe by looking at this chart. Something very striking about this chart. Just, write on the chat and then it's just for discussion so that it's more interactive, that's all.
Demand is more than supply.
Demand is more than supply, correct. But of course, and what do you see is that every single city, whether it's a big city, metro city, or a small city like Vizag, same situation. There is a demand is more than the supply, or we don't have water supply. Water supply is less than the water demand. So what that is telling is that it seems to be a predictable outcome of every water system that there's always a lag. And why do you think what could be the reason for this imbalance? Usually it is because
Population maybe.
Population. Population is growing, but more importantly, the planning of the water is always catching up, because it's very hard to know how much population the city is going to have. So they will build a capacity and they'll just meet it and the population is grown. So there's always a lag between the water planning and the population, or the projection of population is always, not very easy to guess, and also the planning is lagging behind. That is the reason. Okay, so then, so this is one of the, what I'm saying is this is what you see on the ground. Now, what happens when you have a water, city says we have less water supply, it reflects and it manifests to the water users in the form of restricted water supply. So as soon as your supply capacity is less, what are you going to do? You're going to supply less or restricted. And when the water gets restricted, what people started doing in Indian cities and towns is that, what do? We just start drilling a well in our own premise because we want to supplement. Sometimes it may not be enough. The restricted water supply may not be enough, or even if it is enough, it's a perception that we need more than the restricted water supply. And so we start drilling and making hole in the ground to access the water under the ground, which we feel it is our own because it's within your property, not realizing that all groundwater is connected to all the land, and therefore everyone starts to pull water out of it. So what has happened is the water levels have gone down, right? So the water levels have gone down, and it is almost. Can I request people to mute, or Dipankar, maybe you can mute all, so that will be easy. That we are not getting disturbed by the conversations. Dipankar, as a host, are you able to mute? Yeah. Oh. Okay. Great. So yeah, please keep the control of mute with you so that we can manage the noise. Okay. So. So this is the situation of groundwater. Groundwater is getting emptied because we are only taking water out and not putting anything in. Okay, then the next thing, now let us look at what is happening with the sewerage system. So as many of you yourself was evident that this is very disturbing actually. I don't know why even though with the mute it is making noise. Okay, so the sewage system, we find that actually a lot of the capacity required for treatment is much higher than what we actually have. And what that does is when you're having less capacity to treat sewage, of course, that results in local water body pollution because you're going to discharge untreated sewage into the local water body. And what else happens? This is what happened in Bangalore, that the lakes have become a dumping ground for the untreated sewage as well as solid waste. So it becomes a very, toxic concoction. And then this is what happens. There's fire on water, which we cannot imagine, but it happens. And of course, more than 100 million people are living in areas of poor water quality. So you have quantity issue, that the quantity is becoming less available, where the demand is high, and even the water that is available, that quality of the water is also poor. So it's like everything is stacked against the water crisis, and that is what is making the water crisis. That, you know, we are continuously drawing water and in a linear way and finishing it. It's like drawing money from the bank over 100 years and it's emptied now, where the population is grown, and on top of that, the water, that whatever you have, is also polluted. And of course, when it comes to more and more city, more and more hard surfaces, means you are bound to get all the water, storm water, you know, in the form of floods. And this is what you see in every city. It's a normal and the common situation. So these are what I'm showing you, the outcome, what we have got, the result of how we have planned and built so far. This is what has happened. And of course, the World Bank report has put out this statistics, and it's very interesting. What I want you to notice, this blue one is the available water, which is so small, whereas the utilizable water is much higher. So what does it tell? That, you know, all the water that we are throwing away, they count it as utilizable water. That means you can easily decontaminate and use it as a water. It may not be the fresh water, but it is still utilizable because we have now technology to treat the water to our required quality. So because we have not been doing that, we have been extracting, using and dumping, extracting, using and dumping. What that does is it finishes off the water resource and increases the polluted water. So that is the result. Now, another thing that is happening in all cities is the tree cover. This is a heat map, a satellite map of tree cover in Bangalore and how it has changed over the years. Can you see 1973 and today? What a big difference. And what has happened? Because for every development, they're pulling out the trees. It's a story of every city. And this is the result. Now, how does that connect with water? What does that has got to do with water? Any just put in your chat box. Why am I showing the tree cover, statistics when we're talking about water? Is there a relation between the tree and water? And if so, what is that relationship? Yeah, some of you have said erosion, water holding capacity. Yes. So basically, trees are the, are the like lungs or the lifelines, which actually allow the water to seep into the ground and recharge the ground. But as the city gets built and built and built, the chances become less, and the trees are your only chance through which the water can seep in the ground, and even that has been killed off. Then there were a lot of lakes, 1,000 lakes were there in Bangalore. I'm using Bangalore as an example only because Bangalore is right now in front of queue where the water has died. And every city is in the queue. Every city it is going to repeat. The story is going to repeat in every single city around the world, by the way. Every city in the world is on the exact same system, which is not at all sustainable. And Bangalore and Chennai happen to be in front of queue, and let us learn from Bangalore. That is why I'm showing Bangalore example. So trees have been killed. Lakes used to be the place where the water was getting stored and recharged. The lakes would also act as a recharge for the groundwater. Lakes have been built over, big stadiums have been built, depots have been built, everything has been built over, IT parks have been built over it. So it is all sealed. So basically we have sealed the ground for the so-called development, whereas we have sealed our own future also at the same time. Because without water, there can't be any future, whether it's business or living, doesn't matter. Okay, so then let's go to the next slide. I want to show you. This is the site. This is today the condition of Western Ghats, many areas of Western Ghats. Now, what is Western Ghat to do with Bangalore? Western Ghat is a catchment, which is where the trees will take the water in, seep it in, and then as the water gets saturated, it turns into Kaveri River or it feeds Kaveri River. So Western Ghat catchment is the what is feeding Kaveri River and the rivers that feed Bangalore and Chennai. But what did we do? Not only did we draw the water continuously without putting anything back, on top of that, the water that actually gets recharged by nature through the catchment, even that has been deforested out. So from everywhere, it is like we are committing suicide. You know, knowingly or unknowingly, doesn't matter. It is a complete suicide. You've sealed the cities, you've sealed the catchment by taking out the trees. You have no hope left for any water from anywhere. So now, that is, so basically these are the outcomes, okay. I also want to talk about, this is all about the, various outcomes that you can see. Then there are some outcomes in terms of the, what is currently happening in terms of how we use water, whether it is industries, whether it is domestic use, whether it is used in the offices or commercial properties. Let us try and see what is the current situation with how we are using water. So I have a quiz here. Dipankar, if the quiz is ready, you can put it out maybe. So I would like you to answer that industries in our country, and these are not my figures, this is I've taken from the Ministry of Environment has published this, okay, National Water Mission. So industries in our country use, what times more water per unit of production compared to other countries. So where do you think we sit in terms of, compared to other countries, how is our water use in industries? Take a guess and see what your answer is. I would like to see what you think it is. And then I will share what it is, what's the correct answer. So again, you don't need much time, another 10 seconds and we can close the poll. So all of you please pick one answer and reply. So we're talking about water use within industries. How is it, how smart it is or how unsmart it is, that are we using water, how much are we using compared to other things? Okay, so some people think 1 to 1.5, people think, most of the people think it is 1 to 1.5. Okay, let us see. I will share the results, we'll share, but let me ask you the next question. What do you think is the situation with the domestic? Oh, so this is the anyway quiz. So now here in the next quiz, what percentage of water gets lost in our water supply system through leakage and water theft? So, the water supply system, the long system that comes out, brings water all the way from kilometers away from a source and then distributes it. So do you know what percentage gets lost in leakage in that network of pipes? So again, just pick an answer and all the answers will be revealed in together. So I just want you to, because we are talking about, also how we tend to lose or waste water. Water we already have is also needs to be conserved and saved because we are not having enough water. So it is important to understand how much are we wasting so that we know how much can be saved. Okay, what's the answer? Okay, 15 to 25 is the most people have replied. Okay, we'll see. Next, last question before we, now I'm talking about our own household or within offices. What is the water saving potential? That means how much percentage of water can we save by making simple, low cost hardware changes and no cost behavior changes, because the current water use seems to be such that there is potential to improve our usage. That means we can use less and save more. So what percentage could be saving potential? I'm asking what percentage we can save by making these small changes inside the home and offices. And remember all your answers so that when I reveal, you will see, is it different or is it correct? Okay, we can close the poll. Okay. Again, many of you think it's 15 to 20. Some of you think it's 32%. 32% feel it's 30 to 40. Okay, I'll reveal all the answers in one slide only. So the next one because that's the facts. So this is what I got the figures from National Water Commission, National Water Mission. Industrial plants in our country consume 2 to 3.5 times more water per unit of production. 2 to 3.5 times more. So what does that say? We have so much potential to save water, make our water use efficient in the industrial sector. Okay, so now before even you start to get more water from ground and another dam to be built, let us focus on taking back this water which already is there. So because so then the other part is in the municipal sector, the leakage water is lost 30 to 40. Actually, it's an average figure, 30 to 40. Because in Bangalore itself, we lose 50% in leakage. 50% in Bangalore city is lost in leakage. And when you take an average around the city, they have come up to 30 to 40. Now, let us talk about the water use inefficiency inside our own homes and offices. It is as high as 50 to 60%. Our recent research we did Urban Water Doctor, we did our research in the apartment situations and office situations. We were surprised. And also this whole idea that, in fact, their water use is like as if they have got huge gardens, when they don't have that much garden. 300 liters per person per day, 250 liters, 400 liters, whereas we can easily do with 100 liters. It is not, in the planning documents, they'll say 150 LPCD, 135 LPCD. That is also quite a lot. You can easily achieve 100, 80 to 100 is easily achievable without compromising on your lifestyle or on the quality of the function. So there is, so what I am saying is, why am I showing this? The reason I'm showing this is the tendency for us as individuals and for water utility organizations, whenever they want to balance or address the shortage issue of water shortage, they always look at how can I increase my supply? Because now it ignores the idea that the shortage is a function of water demand as well as water supply. So when the supply is less, you'll have more shortage. So you increase the supply to reduce the shortage. But also you should know that the demand, if it is not optimized, if it is not efficiently used, you have so much scope, you're using more water than you need, then you can also focus on how can I optimize my demand? How can I reduce my demand without losing the quality of function? And that part nobody looks at. The water supply agencies are all busy looking at, let's find another pipe, and then they start fighting over the same water because the population becomes so big that there's not enough water. Now they're fighting over the same water. And what do we do as humans, as users? Forget the water utility. When in Bangalore, when they've run out of water, they first go and drill a well, and when that well dries up, drill another well. They do not even look at how much water are they using and is there room to cut down on that water, because they're wasting a lot of water. They buy, tanker water then. So every time it's about, let me get the new water, but not about, would you do that with money? When you have a money shortage, you try and look at, where can you cut down your, use expenses that are not necessary. When you're really in a crisis situation, wouldn't you try to cut down, and then you can add another income or borrow money or get more money? But we don't do that with water. We just never look at supply and demand together. It is never looked at, so it is never integrated. So that is the example of unintegration. So the current water system, as I said, what I call is an extract, use, dump system. So when you have an extract, use, dump system, just replace water with money. What do you think will happen? You'll become bankrupt. So we have become water-rupt. Basically, our water bank has become bankrupt. And why? Because the population is continuously rising. It is not a static population. So if the population was static, even then you need to have your catchments in good condition so water is getting recharged. But you're not paying attention on the catchment also. So without paying attention on the catchment and recharging the natural system, you are continuously extracting, using and dumping that polluted water. And then, so what happens? It becomes, and until the water source is depleted and you start water conflict or water war happens, because cities around the same water are growing, they're accessing the same water, now they don't have enough water and they start fights. And that is the reason is because the management of water, sewage, storm water is unintegrated. If you were to count the rain that falls on a city, and if you quantify it, you'll find that it has enough water to supply. But then we don't look at rainwater as a source, no? We look at it as something to be thrown away because it floods. Of course, there's a good reason for that, but we can also think about how can we look at it as a resource, and that is what integration means. Same as we saw, tree cover, forest cover are lifelines for the water aquifers and rivers, yet we continue to mindlessly destroy them to make room for development, killing every chance of replenishing water. So not only are we ourselves not doing anything, even nature we are not giving a chance to replenish by removing the trees and removing the forest covers. So why we do that? Because the catchment management and water management are not looking at it together. Water management, different department, forest, different department. They don't have any, they don't see the connection, the natural connection that there is. Nature is connected, interconnected, but we don't operate it like that. We operate it in silos, and that is the problem. Now, okay, so I've come to a point I want to ask you. You've seen the results of the, the water crisis. I mean, these are the types of things that has led to the water crisis. So my question is, again, if Dipankar, if the poll is ready, please put it there. So what would you consider as the #1 cause of the urban water crisis? I'm giving you 4 factors. Every factor is, contributes, of course. Who would you rate as the #1 or the biggest cause of urban water crisis? And another way to look at it is, the cause that is controllable, that you can control, it is in your hands as a water, because you are a water user or you are a water planner, anyone. And that's another thing. The water management is not just a job of the water company or water utility. There you go. Many of you do think it is. So the reason I think it is water mismanagement and not the other factors. Other factors are external factors, which are kind of, you cannot control because you've decided the city to grow. Climate change is not possible to control. Urbanization, you can, kind of plan in a certain way, and it all boils down to how do you manage water? Knowing that there is climate change, knowing that there is population. It's not completely unpredictable. The population growth is something you can project and, know how much population is happening. So it is not like, a natural phenomena that we know the city is growing. But for example, Bangalore knew that when they opened the city to IT parks, they knew, they could have easily predicted that it is going to increase the people coming here. It is going to increase the families, schools and everything. So of course, you can't have a policy of, increasing the business in your city without thinking about its impact on water. And that is why water must be a top priority agenda in every single business. It is not the job of only water companies or water utilities. It is for our own security and, future. Water must become a priority agenda for every business, every community, every industry. Okay, so that is very important. So now you understood the kind of, based on what we are seeing the outcomes today, it is a result of an unintegrated system where catchment management is not looking at water management. Demand management is not integrated into supply management. Land management is not integrated. Water, sewage, stormwater are separately managed as different objectives. Each of them have their own objective. Sewage management has an objective of cleaning the sewage to have clean waterways or no pollution. Stormwater has an objective, no flooding should happen. Water supply has a, objective is to supply water. Now, all 3 of them are doing different things. But ultimately, what integrated urban water management is asking people to do is we cannot afford to have one infrastructure doing only one thing. We must have one infrastructure doing more than one thing. If we can build something that supplies water as well as manages stormwater, that is what we want. If we have something that manages sewage, removes the sewage pollution and also solves the water supply problem, we need that. So called multifunctional water system. We cannot afford to have a monofunctional water system. That is the key principle. And how do you, what can guide you into thinking about what type of things you can have? So there are 4 guiding principles I've outlined. And also this is another way to look at, because as I told, the whole idea of integration is looking at the water supply objective, the wastewater objective, stormwater as interconnected. It's all linked together. And how do you link them? Because if you look at it as a resource, then you will be able to integrate them. Then also integration of urban water management is also about integrating with other sectors in the urban areas. For example, the water cannot be moved without energy. It is closely linked with the energy consumption. The more water you use, the more energy you're using. Did you know Bangalore city, because it brings water from a distance of about 150 kilometers, and on top of that, Bangalore is located on a height. It's like a hill station. So the Kaveri water has to be pumped up by almost 1 kilometer height and 150 kilometer distance. Imagine the energy it uses to move that much water. About 1200 million liters per day is moved every day. Out of that, 50% is lost in the system. Now, can you take a guess what percentage of the BWSSB is the Water Supply Board of Bangalore? Their electricity bill, what percentage of their total expense must be electricity bill? Just put on the chat. I should have put it on the poll, but just put on the chat. What's your guess? What percentage of their expenses is made up of just paying electricity bill to BESCOM? BESCOM is the energy provider. Okay, let me see some answers. Okay, you got 30%, 40, 60, 70 to 80. I think that is the correct answer. 70 to 80% is simply electricity bill. So can you see how closely it is connected? So whenever we are making a water system, we need to be also cognizant of what is the energy going to be? Well, how can I make a system that doesn't use energy at all? Because you can make things without using energy also, and low energy. So these are the thoughts you have to start incorporating when you are creating a water system. Vice versa, the energy production also needs water. So when they are producing energy also, they should think, how can I minimize the water consumption? The agriculture has to think, how can I minimize that? The waste management has to think, how do I manage the solid waste in a way it doesn't come and block the stormwater system and impact the water, pollute the water. So everyone is interconnected, not just one-way connection. It's a two-way connection. So as water planners, we have to think about how the other sectors we will interact with. Similarly, other sectors have to consider if the transport planning is happening, so much roads are getting built, flyovers are getting built, how much stormwater I'm going to generate because of these new buildings. How am I going to manage it? How am I going to make it a resource? So this is a thinking that has to be developed when you have an integrated thinking. And it has to be not just for water professionals, but for everyone. Okay, so then the next thing is, so the principles. So I'm outlining the principles of how would you guide your integrated water. So the principles are guiding principles. One, water. Every water is water. It doesn't matter it's brown water, storm water, gray water, black water, doesn't matter. It's water simply because it just has contaminants which can be cleaned up and turned into water. So anytime we are managing the certain types of water in urban areas, we manage 3 types of water. And each of them have their own objective. We need to integrate those objectives, and that is how we'll get an integrated system. We also need to integrate the demand side thinking and the supply side thinking. That before we start looking for new supplies, we have to think, how can I also reduce my demand at the same time? In fact, that should be the first priority. When you reduce your demand, because you're going to use less energy, you're going to use less water to pump from the system. So imagine, Bangalore city not doing demand management. They're fighting over Kaveri when 50% to 60% savings is possible within homes and offices. So but nobody's looking at it. Nobody's doing anything about it, but trying to see how can I get more water from the well, more water from the Kaveri. So we need to integrate water demand management with water supply development. Then the third integration is about, guided by the fact that we need smaller, decentralized, not very large. The larger the system becomes, more problems are created, and then you spend more money to solve that problem. So right now in smart cities, they're not at all looking at decentralized. They're only looking at how can I, this large system which is unsustainable, but now I want to fix the leakage. So how can I smartly detect the leaks? So you can detect the leak in a very old city with a smart system, but can you fix it? How will you fix it? It takes a lot of money to go underground, pull out the building. How are you going to do that? So let's become more smarter, not just smart. Smarter thing to do is create smaller systems. Create a new system, and whenever you are creating a new population, create a new decentralized system and make it circular, not linear, where everything is going to be have a use by date. Right now, every city is on a time bomb that as soon as the centralized system dies, water finishes. So circular system is what you need. And how do we create them? By making sure we are integrating water recovery, regeneration of water within the water supply. So it's not just a water supply system. Water supply system has to incorporate a water recovery, simply because 80% of our demand we need different qualities of water. We don't need one quality water and that can be supplied to. We can make non-potable quality water for things that are not for drinking. Then the other thing is we have to integrate any urban forms, whether it's road, whether it's buildings, any hard surfaces that we build in a city, that we become water sensitive about it. We understand how does it impact the water cycle, and therefore how can I create a design in the building that will generate less, will retain the stormwater rather than throw it out, that will recycle it so it doesn't go out. So you have to become water sensitive, and that happens by integrating all the three principles within the urban design and within the city infrastructure. So whether it's a road you're building, whether it's a dam, whatever you build in the urban system, you have to make sure you are following the three principles of one, water, demand and supply, balance, and create a decentralized circular water system. So again, these are abstract concepts. So how does it look like if we did it? If we did it in reality, what would it look like? So that is why I want to take the example of the examples in Australia, where I have been personally in each of the projects. I've been personally involved, so I have to pick those projects. It starts with my own journey in Australia with my water career also. So I'm going to show 4 of them. Each of them shows one of the principles highlights one of the principles, and it will have certain aspects of all the other principles. So the first one I want to talk about is the Sydney Olympics Park, and it has a system called Water Reclamation and Management Scheme. And another one is so I'll give you the 4 things. And before I start each case study, I want to let you know, please listen to it carefully, because it's almost like a quiz. After each case study, there'll be 2-3 questions as quiz asked or as a poll. So you'll know, whether you were listening to the presentation carefully. So I would like to give you an alert that please pay attention to the presentation on the case study. I just want to check the time. How are we going? Oh, it's almost half an hour left now. Correct, it's half an hour left, no? Okay, so we start with the Olympics Park presentation. So this Sydney hosted the Olympics in 2000, okay? And they did a very smart thing, because they knew they have to build a lot of infrastructure for the sporting stadium, and as anyone would need to when you host an Olympics, there's a lot of infrastructure that would need to be built. And so what they did was they did two smart things. One is they picked the most contaminated land in Sydney, because Sydney has a history of the British colonies which had been kind of using some of the places. For this particular site was a very contaminated site, because it used to have the state abattoir, because it's very high on meat. They were making meat for many years in that place, and abattoir produces a lot of toxic contaminants, and the entire land, and also on top of that, it was being treated as a waste dump for a long time until 1990. And it had become completely polluted. So they had stopped using it as a landfill, but it had become completely polluted. So they thought, let us use this opportunity to completely change and clean up this site. And that's what they did. So and also the second smart thing they did was the Australian government made it mandatory and made it a very like a big propagation of sustainability. It was a very new concept in 1995, around that time, 98. Putting sustainability very actively in every government department, whether it is state government, central government, local government, water utilities, energy utilities. So what were they helping people to do is to help them understand, what does sustainability mean for a municipality? What do we need to do in order to be so-called sustainable? What does a sustainable, what does a sustainable water policy look like? What does sustainable water plan look like? So because of that, they wanted to showcase that we will build, and they built one of the first and the largest integrated urban water system. And it is a sustainable, because when you do an integrated urban water, it also becomes a sustainable system. So they decided we will build the entire water required for that area will be using sustainably, and we will demonstrate as an example that how it can be done. And that was one of the first one, and I had the fortune of working on that project, because of which I came to know more. And so it is integrated within an old, highly contaminated waste landfill site, which was also, they did a lot of work on remediation of the site. So they have done, if you go and Google this, write down Sydney Olympic Park contaminated site, you will get, if you're interested, a lot of remediation work they did, and they completely transformed that. If you look at that place now, nobody will believe how polluted and contaminated it was. So what's the context? There was a 640 hectare site. They decided they will build all the required stadium, the parks for all the Olympic activities, which can then later, after the Olympics, can be used for multi-purpose. It could be used for, holding events, entertainment centers, offices. So they designed it in a way that after the Olympics is over, those very stadium can be also used for other purposes. So it has 640 hectare site. 2/3 of that area was turned into parklands, beautiful parklands. If you go and see now, and then major sports and stadium facilities, residential complexes were built, commercial office spaces were built, and also for the future, for Olympics, whatever was required was done, and also they made enough infrastructure for the future also. So this is the context, and in that we have the system called RAMS, or Water Reclamation and Management Scheme, about which I'll talk about. So the design principle was, of course, because it was integrated urban water management, they said we need to build, whatever we build must minimize sewage discharge, must reverse the stormwater impact, must harvest stormwater, treat it, reduce potable water demand, reduce the need for using fresh water. Okay, so that was the principle. And so this looks a bit not very clear diagram, but I want you to focus on the fact that all the facilities, this is number one, brown color is number one. So all the sewage generated from the facilities are treated in a thing called water reclamation plant. And it produces, whatever is produced in that is diverted to the water treatment plant. Okay. Then the stormwater from this all the facilities is also diverted to a stormwater treatment pond, which is then stored in a brick pit. There's an old, because it was also a site where they used to have a brick making facility, and there was a big brick pit there. So they used it to store the treated stormwater. Then the treated sewage and treated stormwater would be treated in the water treatment plant to produce all the recycled water, that is number 5, was needed for the facilities and the future facilities. So this is, in short, the entire ramp system. So what you can see is that sewage is being reused, treated and reused, stormwater is being treated and reused, and basically, so they have a water reclamation STP, which is made up of, sequential batch reactor. There's biological nutrient removal happening. There's disinfection happening. Then the stormwater, they use the brick pit. This is the brick pit they used for storing the, that brick pit is what is stored. Then there's treatment with wetlands. That is the stormwater part. And number 3 is the recycled water production, where they do the advanced treatment using microfiltration, reverse osmosis, and chlorination. So this is basically the facilities. And this is how it looks like. They kept it, made it in a glass so that people can come and look at it, because it was also for demonstration purpose. So they turned it into a beautiful, space for people to come and visit the plant. So what does it achieve? It achieves drinking quality water demand has reduced by more than 50%. So very small percentage of demand requires drinking quality water. Then they also 800 million liters per year of sewage is treated and reused. 700 million liters of stormwater is harvested and used beneficially. So they created a lot of wetlands out of the treated stormwater, so that also attracted a lot of biodiversity. So it has become a beautiful biodiverse area. And 850 million liters of recycled water is supplied every year to 15,000 to now there must be 20,000 customers. So that is the population it is servicing, this system. As you can see, it's a small system. This is called decentralized system. So what kind of water they're using the recycled water for? Toilet flushing, car washing, any wash downs, irrigation of parks, residential gardens, playing fields, clothes washing, even washing machine. It has a separate pipe coming, supplying you the non-drinking water, but clean enough to not soil your clothes. Firefighting, fountains, cooling towers in the offices, construction purposes, because new buildings will be coming up, so they're using it for that. Swimming pool filters, backwashing, and then so these are the variety of uses so all of that, normally in the traditional way we would be supplying more of drinking quality water, where that has, when you start looking at sewage and stormwater as a resource, you can start to supply this. So just to give an example, in a typical office building, almost 88% of the entire demand for irrigation, cooling tower, all this would be replaced by recycled water. So you only need 12% of water required for drinking quality. So that is the impact you can see this system has made. Then I wanted to give an example of a multifunctional. So for example, this brick pit, I told you, it stores the stormwater, treated stormwater, before it is pumped to the treatment plant. So, and of course, it always has more water than it is needed every day. So that was used to also enhance the population of this green and gold bell frogs are extinct population. So for biodiversity purpose, they used it to, and then what they did, they created this deck so people can walk around it without disturbing the biodiversity. So they made a beautiful walkway on top of the brick pit. So what I'm saying is that any infrastructure, it has to be thought about how can you use it for environmental purpose, for social purpose, for the purpose of water creation, but excess water can be used for environment purpose. So that is also okay. So that is a very good example of a multifunctional infrastructure. So it's become a beautiful recreation spot now for people to come and enjoy the biodiversity. Okay, now quiz time for the Sydney Olympic Park water reclamation systems, case study I presented. So the first question, Dipankar, would you like to put the question? Okay, so what's the approximate size of the development? I think we don't need long time. We just close the poll quickly so that we can move ahead. Okay, so let's see. Yes, good. So 61% people are paying attention to that number. So 600 is the correct answer. 640 hectares to be precise. So just, it's for fun. Then the next question is, 1 minute. What percentage of total development area is allocated to parklands? Is it 1/3, is it 1/4, 1/2, or 2/3? Okay, so again, it's actually 2/3 is the correct answer. Some of you got it right. 1/3 people got the 2/3 answer right. So that's fine. Okay, so one more question. I think there may be two more questions. Yeah, two more questions to go on this case study. And I'm able to see some comments there. I think I would be happy to share the presentation. That's not a problem. I will share it with Professor Sarode. Okay, which one of the sequence is false with respect to the recycled water production in RAM scheme? So take a look at this. If it doesn't apply, then that's false. What is not happening in the RAMs is what you have to tell. Is there a recording of the session, Professor Sarode or Dipankar?
Yes, madam. It's going.
Okay, maybe then everyone can share the recording will be a best thing to, because just the presentation may not be sufficient. So I would suggest that you share the recording. Okay, so time to submit the poll or look at the results. How many got it right? Okay, so the correct answer was the last one is the false, because the sewage doesn't go to the brick pit. The brick pit only takes the stormwater, treated stormwater, but that's okay. So yeah, it's like first time you are looking at it, it's very complex system. So understandable. But yeah, this is just to get a bit break from my voice. So you get a, okay, so now we move to the next last question. What is the volume of recycled water produced and supplied to customers? Those who are asking certificate, we should see if they passed the quiz. Okay, let's see the answer. Yes, 850 million liters per year is the answer. And 700 million liters is the stormwater that gets treated. Not all of it is used. Some of it is kept in the pond to enhance the environment. Okay, so that's that. So now let's move to the next case study. So what I've done is I am trying to give one case study of where water and supply and demand are integrated. And it is very rare for any utility to do, and Sydney Water is one of the first and the largest, it has one of the first and largest water demand management program. And I had the fortune of actually being part of developing it. And in fact, it was the time when until I got involved with this project, I was an engineer, complete just designing systems, commissioning, operating systems. But when I got I actually got a job with this think tank group who are helping water utilities understand what sustainability means. And so they hired me as, because they needed an engineer in the team. It was a multidisciplinary team. I did not know what are they doing. I just thought they need an engineer, and I joined. Only after joining, when I was working on this project, I understood what is it that they were doing, very different to what I had been doing, designing plants. My job was to crunch the numbers, to tell Sydney Water, to show Sydney Water by showing, by evidence, by analysis, that if you invested this many millions of dollars in helping people reduce their water consumption. So we were telling Sydney Water, you go and change the shower heads, change the taps for the customers, and you spend money. But even when you spend money, it will make a business profit for you. I was very, very intrigued because when a company or a Sydney Water utility, it's a state-owned entity, it is charging money for water. So when you're making money out of water, why would you go and spend money and ask them to reduce the water? That means your revenue will go down, no? But no, when you start doing the complete integrated analysis, you find that because they have also got expenses to pump the water, to drive the water, to build new water dams for the new population. So by doing this demand management, they actually make much more profit. By spending money on that, they're making money. And that was, I learned firsthand because I was the one crunching the numbers, talking to the engineers, getting the data and analyzing it to help them prove that you must invest. And after the work that I did, the Sydney Water, I'll show you what they did in this. This is the case study, okay? So it was the first and the largest demand management. You know how much they've invested? $60 to $90 million every year for 10 years. They reduce the water consumption to such a low level that now they've reduced their demand management budget. They don't spend this much. Initial 10 years, they spend that much. Now they've reduced, but they're maintaining the optimized demand to help help everyone keep the demand low. So what did they do? I want to share that. So also I want to show you how they gradually saved. So they started. So soon after that Olympic project was finished, I joined this project. So we were he helped them understand the benefit of it just before 2000. And then they started investing slowly. And this is the savings, yearly water savings they achieved since 1999, after we proved and made a case for them to invest money. And can you see, what did we ask them to do? We asked them to put in place some regulatory measures, whatever they can put, some regulation measures in terms of, what type of new buildings should have these things. That is a regulation they can put. Recycle water, some recycle water schemes we identified, small schemes. Leakage reduction. Can you see this dark blue? That has got the leakage reduction, lot of leakage reduction they were able to do within their own system. Then we created a business program. That means we are helping every type of hotel business, office buildings, different types of businesses, showing them how to go and find the water saving opportunities and giving them some grant to go and implement those solutions so that they reduce their demand. Then residential outdoor, small quantity they can reduce. And residential indoor, can you see how much savings they made over? So now if you were to look at the savings they were making in around 2009, it is almost 90 billion liters of water. 90 billion liters. Now, what does that mean in terms of the overall water demand of now next graph will show you that. So can you see what happened? 91, this was the demand population. This is the population graph, line graph, is how the population is increasing. And what is happening in our cities, you saw the supply and demand is more than the supply because we have a reason that population is, that's what happens, that the demand should go up. But what is happening? Look here. So now the population, even though it is on the rise, they were trying to do some water restrictions. So they got, because it was a long drought. Australia always has 10-year long droughts. So they were having some water restrictions. They reduced it. And then after the water drought went, the people started using again. So the water demand went up. And here is when we started introducing the water efficiency program, demand management program. So then even though this is rising, now can you see how much it has brought down? Over 10 years, and then they continued to invest. But when they stopped investing, again it went up. But now they have recently introduced more budget to put the demand management. So for this period, they felt because they reached a low in here, they said we may run out of money if we are making too low. So they stopped investing. But always it happens that the demand will start going up. And then they brought that demand management program again recently, and now they have started to make the reduction again. So what I'm saying is that what is the difference they made? Almost, if you compare this dot point, to this dot in 91, they made almost 100 billion liters they have saved. So what used to be 675, almost it is now 575 gigaliters a year. So it's almost 100 gigaliters or 100 billion liters of water saved just by putting water saving measures. Population increased by 26%, but the demand has only gone down, not gone up. This is the magic of demand management, which very few people pay attention because you don't get to build a lot of engineering infrastructure. These are small changes which are most of us are very shy of doing because it doesn't look exciting enough. But we have to pay attention to them. We have to make them cool. Okay, so this is so now I just wanted to show that they did two things: fixing leaks, they decided to do, and they are going to save, they almost save 44 billion liters a year is what they now going forward. This is the projection that they are continuing to invest in the leakage management, and they'll save this much a year. So that means that much population, even if it increases, the water demand is kept under control. And they made a profit of $450 million in spite of spending nearly $60 to $90 million every year. And they are now going forward, they are making $1 billion investment for 10 years. That means 1 million per year, 100 million per year investment to manage the leakage. Okay, and also to help the people save water in their house. So it is to say, what is the program they have? See, they announce, this is called Water Fix program. They say, call us on this number, we will come and fix your leaks for free. We will change your shower head for free. We will change your taps for free, and we will repair the toilet leaks. And because they know that they're going to make money by helping customers save water. So this is a Water Fix program, which is very popular. It is advertised heavily so that everyone makes sure there's no excuse for householders to to not take this help. And then they published best practice guidelines for water conservation in hotels, water conservation in office, and they're all public domain available. So if you are interested, if you are in an office building, go and pick up this guideline, because these guidelines are telling you what can you do on your own. You don't need to get anyone's help. They're all low-cost solutions that you can do. Before you even start building rainwater harvesting, you have to first do this, because this is going to save you more water than what rainwater can save you. Because save this, then you add on top of that rainwater harvesting. Add on top of that the grey water recycling. And that way you build your water bank. And then suddenly you'll find, I don't need any water from the outside. I'm doing fine. So in fact, in Bangalore, the model that I've developed called the water scorecard model, it helps the buildings reduce 50 to 100% water that they are importing or using unsustainably. But out of the 50 to 100% saving, 50% is inside the house, small changes. Only later on you will get more savings. If you're not doing the household savings, you'll get 10% saving by doing rainwater harvesting. But that is not enough. You have to do inside saving. Inside actions are very important. So the next quiz is about this. If you're paying attention. So Deepankar, can we have the next two questions? Okay, so the question is, what is the approximate reduction in volume of water demand that has been achieved since 1991 till 2019 through the water demand management despite the population rise by 26%? So if you remember the graph, how many billion liters has been reduced, reduction has been achieved, even though population has gone up. Okay, yes, many got it right. 100 billion liters is the correct answer. Next question, please. Okay, the next question I've asked is, what is the amount of money that is planned to be invested to save water that gets lost due to leakage in the water distribution network? Is it $1 billion over 10 years, $10 billion over 5 years, $10 million over 10 years, or $5 billion over 10 years? Okay. The correct answer is $1 billion over 10 years. Okay. So anyway, that was just for fun, as I said, nothing, no problem if you. And because of the time, what I'm going to do is to, there is 2 more case studies, but I think I'm going to jump to the one which is more interesting, which is more recent also. This is an old one. So I'm going to skip this, okay, please, if you don't mind, and then let's move to the, this case study is about very brand new. It's a old city area, often requires redevelopment because it has to accommodate new population. So there's a, this is a urban renewal and redevelopment site. It used to have an industrial site citing a brewery, Carlton United Breweries, huge big factory making beer, right in the middle of the city. There's a university opposite, there are shopping center around it, and this site, ugly site was there, but then they decided now it's time for it to be replaced with a residential zone. So they, kind of made it open for development within the place, apartments within the place. So that is the context, and of course, that site was so ugly and had no public access. Now it provides, this entire site is completely transformed, and it provides nearly 1 hectare of parkland and public open space. So this is the building that has been built in this old area. Can you see the old buildings? The old restaurants and things like that. And then this sits here, and it accommodates a population, a large population, I think about 20,000. It has certain, we'll see the numbers. So that, but again, what did they do? They made sure it's an integrated urban water system. So Central Park, it's about 6 hectare of mixed use precinct. Precinct means like a neighborhood or a layout. 2,400 apartments. So, you can take like about 3 people in every apartment. So that's around 72,000. No, 7,200, 8,000 to 10,000. But of course, there's also floating population, 400 hotel rooms, 1,000 student accommodation because there's a university nearby, 6,000 square meter of commercial space, 20,000 square meter of retail space. 1/3 of that space is allocated to open public green space. So this is how the green spaces are accommodated around the building. Then the recycled water, so we're talking about water in this place, is distributed within the precinct to supply water to, again, similar to the Sydney Olympic Park cooling towers. So wherever they could, they've replaced it with recycled water, irrigation, toilet flushing, and washing machines. Then the scheme is also exported across the road to the university. So even the university makes use of it in their cooling towers and their toilet flushing. They have excess, like surplus water. And it's also, the entire plant is remotely controlled. It's a compact plant in the basement. It produces no noise, no odor, and it is easily remotely controlled. So this is what it looks like in the night time. So wastewater is collected from the buildings. And also what they do is, there is a practice in Australia called sewer mining. Sewer mining means because the sewage system is already going in that area because it's an existing city. So they take sewage from it, treat it, and turn it into usable water. So even if because see, sometimes when you have a recycle system, sometimes you can have less water being generated because you're efficient, but you need like a bit more water for. So what they are doing is they're taking water from the sewage system, as mining it. They're calling it sewer mining, and that makes up the shortage in the volume. And they treat it and use it. Top up from stormwater runoff and rainwater. And wastewater is treated to the highest quality using membrane bioreactor and RO. This is how the plant looks like in the basement. clean. It is water is treated through 8 filtration and purification processes, including MBR and RO. And it requires minimal space, doesn't generate noise, no smell, and it's easy to accommodate in a high density building. And this is the sequence, it takes you through. You can have a look at that. So it's treating all forms of water. So it's used for treating the wastewater, sewage, and the storm water. It also includes, collects rainwater as well. And also it's supported by local energy. So they also produce energy in this building, using a tri-generation system. And that energy is supplied for running the plant. So the quiz, just 2 questions in this. Oops. You want to put it there? I don't have it on my slide. If Deepankar, you have it. Okay. So the Central Park development is built in an old industrial site at the heart. The old site was occupied by this. You'll remember. Everyone will remember this, I hope. So it used to be a warehouse, it used to be a brewery, it used to be a bakery or an abattoir. Okay, let's see the answers. Yes, brewery is the correct answer. And one last question, and then I'll do a conclusion. Last question, please. Okay. What proportion of the 5.8 hectare of Central Park has been dedicated to open space and parks? Okay, let's have the poll answer. Yes, it's 1/3, so that's good. Most of you got it right. Okay, so in conclusion, I just want you to note this. So some agency did a study of 50 cities, and they assessed its sustainable water sustainability system in each city. And they used these 3 criteria, that how resilient it is, how efficient it is, and the quality. So based on that, it ranked. And what I'm trying to say is that integrated urban water management is all about building more resilience, more efficiency, and more quality by creating multifunctional water infrastructure. So Sydney ranked 8th and Delhi ranked the last. I think what we need to do is that let us resolve that this integrated urban water management, one of the most important, one thing if you can remember out of this presentation, which is I've saved it for the last, is that it is completely doable at your own property scale. You do not need any external, some municipality to get ready, create a policy, create a rule. No, you can do it at your own site. It is technically doable. It is financially affordable. I just am trying, I've come back here only with one mission of making integrated urban water management socially doable, socially aware. Everyone, if they know that it is magic, it can reverse the water crisis situation, one property at a time. And that is all you all need to take away. You don't, even if you're not a water engineer, you are using water, you are at a property that is using water, start thinking, how can I create an integrated system that will take me, make me sustainable, resilient, and efficient forever. Not when the, after some time it will die. No, it is forever. And that's why you see my tagline our mission of Urban Water Doctor is to enable all the water users to make their own oasis. Your property is your oasis if you use integrated urban water. In a water-stressed desert, your city may be water-stressed. It may be a desert because they have an unsustainable system. They're somehow trying to deal with it. So let's not tell what the government should be doing. Let us see what can we do, because it is doable. If it is doable, there's no excuse. So I have come back only with that optimism that it is not about the government. We should help the city, we should help the government by helping ourselves using an integrated urban water management approach. And that is, it doesn't matter who you are, water should be a top priority. And as soon as you start involving women, they will also start to contribute their own way of thinking, and you get a diverse way of thinking and make this forward. And if you need to contact me, please do. I can run training program for you to know how to do it. We can help you to get a water scorecard so you understand the need for the integrated urban water management. We do a water scorecard at building level, at family level, because we are saying start with your own family. Forget, building. Start with your own family. Can you save water? 50% saving. Can you do your 50% saving? You have no excuse of association, cooperative society, government, nobody. It is in your own hands. Low cost changes. No cost changes. That is all we help people do. So thank you very much for your attention. And I really hope you take away that key message, if nothing else.
Thank you, Dr. Bhakti Devi.
Yes.
For a very nice and informative presentation. By sitting in Mumbai in this pandemic situation, people
Yes.
got a very good case studies and information of developed world. Okay, so now I request our TechCube coordinator, Professor Padma Devarajan, to
Yes.
speak on the lecture.
Sure.
Thank you, Professor Sarode. Thank you so much. Actually, I came in late because I was in another FDP. I'm basically not an engineer. I'm a pharmacy person, professor, and former head of the pharmacy department.
Right.
And this lecture has been organized under the World Bank Technical Education Quality Improvement Program, which I handle for the Institute.
Right.
I came in late and I really thought I missed something. It was wonderful. I think from 12 I joined.
Okay.
And half an hour. And a lot of things that really have created a huge impact on me. As a water user, as somebody who's lived all my life in Mumbai, a city stressed for water. Every year there's a challenge. And in fact, incidentally, yesterday we were stressed for water because of some electrical breakdown, not a water problem. But water is a comfort situation. If you know your tap has water, that's when your mind functions in other things. So it's very, very important. And I think I really love that last sentence you made, or your tagline, make an oasis in a water-starved
city.
I think that was really fantastic, and all of us must look to that. And I would really urge Professor Sarode to be in touch with you to see whether we can actually implement this on ICT campus before the TechWhip program is over. Maybe we have some funds to divert if we need to do this on the campus. So that would be really nice. And it's also wonderful to see that we have a woman engineer.
Yes.
Engineer, and I'm assuming you're a civil engineer?
Yes.
Absolutely. So that is one field where the number of ladies is really, really sparse. And in that field, to be somebody who has really come up so beautifully, fighting against, competing, I will say, with a whole, a set of people, and establishing yourself, I think, in a societally relevant area. I think that's really wonderful. What you've chosen, I saw for your PhD also was urban water.
Yes.
And I think it's really nice that you're continuing that as your career. And the passion with which you presented whatever you presented today, I think that is very striking, and that passion is really infectious.
Thank you.
That's something that I think women can portray more with passion than men.
Absolutely.
Not that men cannot, but this is one maybe positive feature which we should exploit. Particularly, I feel your outreach must be to smaller groups as workshop groups.
Absolutely.
And I don't know, I was just wondering because maybe we get in touch with you.
Yes,
And-
please.
But is it
Absolutely.
possible to have a workshop kind of
Yeah.
situation
In fact,
over 2 days, 3 days, so that people
Absolutely.
actually understand in their homes what to do? We could begin with faculty.
Absolutely. I've designed modules. I've designed modules for you to learn about doing at different levels. You can do, look at your, what do you do at a house level, at a building level, at a neighborhood level, whether it is an existing, how do you retrofit, how do you, add to it and make it water sufficient, how do you do a new ones. So we have all sorts of modules, and also I have conduct training for people to become water conservation consultants, because we need more of them out there. We don't need to, you don't need a technical, you just need to have interest in saving water, and you should be able to count. So if you have these two qualities, you can become a water conservation consultant, because people need this. We are not counting water. That is our biggest problem. When you don't count water, you will not manage it. So this, if you go to the website, please look up the website. It has got various, and of course with universities, I'm talking, we can devise, as you say, summer, like a workshop, which can be even held online. That is the beauty nowadays. That, I've been holding this water conservation consultancy training online, because people from Pune, Nagpur and all are able to participate, and they're doing it practical. It's a practical exercise. They're using their own building to learn how to do it.
Right. So I think under TechWeb, societal outreach is also very important for us.
Yes.
So maybe we can use this opportunity, and I'm very happy I came in. Otherwise, probably I would have missed this lecture if I were not coordinating this program. We're so busy in our own daily activities. It's very
Yes.
tough to fit in something. But then when I saw the subject, and then I told Dr. Sarode, I normally come in. But today it clashed with another program of mine, which was related to
Right.
the subject. But I said,
There's a recording of it. You
at the
You
end.
can watch the recording. Yes, and I also urge all the participants to please connect with me on LinkedIn, because on LinkedIn I post updates on any training that are being announced. So people want to do it on their own. Some things they can also keep. And also I share a lot of posts on the work that we are doing. So that way they are also learning about what is possible.
Yes, so I must really thank you very much for this brilliant session, for all the passion with which you have delivered the talk, and I'm sure you have motivated most of those in the audience. So on behalf of ICT, I really thank you, and I can assure you we will
We need more and more people. Thank you.
So
Thank you. Appreciate it.
go ahead with
Thank you,
questions.
Professor Sarode. We both,
Thank you.
Professor Sarode and I have been classmates. It is so wonderful to actually come and give back. Yes, we both were in the same batch, same class.
Right. So you are from VGTI.
Yes.
Okay, it's a neighborhood.
Yes, absolutely.
I am a student of ICT also.
I see. Yes, I know. Exactly. Because that's all, we all Bombayites have been studying there and, coming back. I also was teaching in VJTI before I migrated to Australia. So that's what. But
Thank you.
great to come back.
For your information, Dr. Bhakti, Professor Padma Devarajan is also a well-known figure in pharmacy, because our pharmacy department ranks number 4 in India.
Oh, yes, I know.
And
I know
she's
UBCT is always been. Absolutely.
She is having a lot of patents and all credit
Right.
to her and her departmental colleagues for bringing our
Right.
ICT in limelight. For all the participants, I must say that our Department of General Engineering in ICT conducts a master degree program in plastic engineering, and besides that we have 4 programs of PhD in civil, mechanical, electrical and plastic engineering. This is for information of all, because many of participants may not be knowing that UDCT means only chemical. No, besides this also we have so many other advanced studies avenues available, and right now in my department more than 60 people are doing PhD in various topics. So that's why I always select the topic which will be useful to one or the other student directly or indirectly, and will get connected to these experts. Okay? with this, I also thank all the participants for sparing your
Yes.
valuable time.
Yes.
And you can always connect to Dr. Bhakti Devi on the website, and you will get all her contact details on that. And I think we have overrun the time because of
Yes.
that curtail our question answer session. And I don't want to come in between your lunch and so thank
But
you.
it was also interactive, so people participated. I want to thank them for that.
Yes, yes.
And please visit the website, and there's an email address, urbanwaterdoctor@gmail.com. So you can write an email also, and we can connect, no problem. And LinkedIn, very important. LinkedIn is the best place. We can even message each other and talk to each other there.
Thank you. Thank you. Thank you. Thank you, man. Thank you.